Good morning, students. Welcome to the class. Today we will discuss about reflection and shear. Okay, in 3D geometric transformation. In the previous class, we have discussed about the rotation and translation and scaling. All the three basic transformation we have covered. So today we discuss reflection and shear. So let us discuss in detail. Reflection. Reflection is a mirror image of the original object. The reflection concept also we have discussed in 2D. Okay, 2D geometry. For this reflection, axis and reflection of plane is selected. That means in the reflection, we select the axis, in which axis we can reflect the object and in which plane we can reflect the object. Okay. So in 3-dimensional reflection are similar to the 2-dimensional reflection. We can differentiate 2D and 3D reflection by adding z-axis. In the 2-dimensional coordinate, only x-axis and y-axis are there. But in 3D reflection, we add another axis, which one is our z-axis. Okay, x-axis, y-axis and z-axis. So, the z-axis shows the depth of the surface. Okay, in the reflection process, the size of the object does not change. The reflection is 180 degree about the given axis. The size is as usual, it is constant, does not change, does not vary, but it only reflected the 180 degree in the given axis. Okay, for reflection, plane is selected as xy plane, xz plane or yz plane. Okay. So here is a picture. In this picture, the image is there. This one is our image. This one is our image. This flower and this moon is reflected is here. Okay. It looks the image size is same. Okay, so here the matrix is x-axis. Matrix for this reflection is, or different axis is x-axis, y-axis and z-axis, and the different plane is xy plane, xz plane, yz plane. So these three planes are there and these three axes are there. In this way we coordinate the 3D image. Okay. So there are three types of reflection. One is reflection relative to xy plane. Second one is reflection relative to yz plane. Third one is reflection relative to xz plane. In this way we categorize the reflection in three different ways. Okay. So first we discuss reflection along with xy plane. Xy plane means this side, x coordinate and y coordinate, z coordinate is above. Okay. So in the xy plane reflection, the value z is negative. Okay. Xy plane, here is your reflection along with x. This one is our x-axis. This one is our x-axis and this one is our y-axis. Okay. Here z-axis is there. But when we reflect the image, then the z axis can be negative. So in this way, that means the original position is coordinate position is x, y, z. But when we reflect the image and the destination position is x1, y1, z1, so here x1 is x0, y1 is also y0, but z1 is minus z0. That means it is negative. This one is positive. In this way, when the z coordinate position is reverse it will, this one is our negative position. Okay, so the matrix form of this reflection is x nu, y nu, z nu and 1. In 3D matrix, 3D coordinate position, the matrix form is 4 cross 4 matrix. Okay, in 2D coordinate position, the matrix is 3 cross 3 matrix. Okay, so here the destination place is x nu, y nu, z nu 1 equals to the xyz or original position into the reflection. That means x nu, y nu, z nu 1 equals to 1 0 0 0 0 1 0 0 0 0 minus 1 0 0 0 0 1. Okay, here minus 1 means z position is negative into x old, y old, z old 1. So this one is our matrix for the reflection relative to xy plane. Okay, so this matrix form, all of you remember it. This is very important to solve the problem. Okay, next come to the next category, which one is our reflection along with xz plane. Okay, in the xz plane reflection, the value of y is negative, x axis is constant and z axis also constant, but y axis is negative. Okay, so that means x1 equals to x0, y1 equals to minus y0, z1 equals to z0. Okay, so in this way, here this figure, it will show you how the y axis, this one is your positive in the original position, but when we reflect it, the y axis is negative position. So in this way the figure is looks like. Okay, the matrix form for this reflection is xz reflection is x nu, y nu, z nu 1 equals to 1 0 0 0 0 minus 1 0 0 0 0 1 0 0 0 0 1 into x old, y old, z old 1. Okay, in this way we can reflect the image in xz plane. Okay, so this matrix, all the matrix formulas are also remember it. Okay, now next we discuss reflection with yz plane. In the yz plane reflection, x is negative. In the xz plane xz plane reflection, y is negative, and in the xy plane reflection, z is negative. Okay, so in the yz plane reflection, the value of x is negative. Okay, so in this way, x1 equals to minus x0, y1 equals to y0, z1 equals to z0. Okay, so here in this figure, this one is our original position and this one is a reflected position. So in the original position, x is positive, but in reflected position, x is negative. Okay, and the matrix for this is x nu, y nu, z nu 1 equals to minus 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1 into x old, y old, z old 1. All these things, all of you remember it. Okay, so this one is our reflection. Reflection can be divided in three types. One is three category. One is xy plane, another one is xz plane and last one is yz plane. In the xy plane, z value is negative. In the xz plane, y value is negative. In the yz plane, x value is negative. Okay. So next we discuss about shear. Shear also we have covered in 2D. Okay. So in shear, its shear transformation can change the shape of the object. It is also called as deformation. Change can be in x direction or y direction or both direction in case of 2D. Okay. If shear occurs in both directions, the object will be distorted. But in 3D, shear can occur in 3 directions. In 2D, it can only change the position in only x direction or y direction. But in 3D, it can occur in 3 directions. That means x direction, y direction and z direction. Okay. So, there are 3 versions of shearing. That means shearing in x-axis, shearing in y-axis and last one is our shearing in z-axis. In this way, we can shear in 3 different versions. Okay. So, let us discuss one by one. Consider a point object O has to be sheared in 3D plane. Okay. So let us discuss how it can be. Let initial coordinate of the object O is x old, y old, 0 old. That means this x, y, z coordinate position. Okay. When we shear the object O in x direction, then the shearing parameters is shx. When we shear the object O in y direction, then the shearing parameter is shy. When we shear the object O in z direction, then the shearing parameter is sz. Okay. So, new coordinate of the object O after shearing is x new, y new and z new. Okay. Okay. So, first we discuss shearing in x-axis. Okay. So, shearing in x-axis is achieved by using the following shearing equation. So, first we find out the x new equals to x old as usual, y new equals to y old plus shy into x old and z new equals to z old plus shz into x old. Okay. That means when we rotate the object in which direction, then the direction which we want to shearing, that was constant. That means here we shear the object in x-axis, so the x value is constant. So that's why we can here write x new equals to x old and the y and z value can be changed. Okay. But in matrix form, the equation may be represented as x new, y new, z new 1 equals to 1 0 0 0. This one is our constant. Okay. Then shy 1 0 0, shz 0 1 0, 0 0 0 1 into x old, y old, z old 1. So this one is our matrix form in x-axis. Shearing matrix in x-axis. Okay. All of you remember this. This one and this one. All of you remember this. Now next we discuss shearing in y-axis. Okay. Shearing in y-axis is achieved by using the following shearing equation. Okay. When we shear the object in y-axis, that means y value will constant. Okay. So y new value equals to as usual y old value. So but in x new value equals to x old plus shx into y old, and z new value equals to z old plus shz into y old. That means here y old value can be multiplied in the parameter shx and shz. Okay. The matrix form of this axis, y-axis shearing, is x new, y new, z new 1 equals to 1 shx 0 0 0 1 0 0 0 shz 1 0 0 0 0 1 into x old, y old, z old 1. Okay. So this one is our shearing matrix of y-axis, and this one is our equation. All these things are, remember it. Repeatedly I am telling you all these things, all of you remember it. Now we discuss shearing in z-axis. Okay. Shearing in z-axis is achieved by using the following equation. So here also z value will be constant. That means z new equals to z old. But x value and y value will be changed in the destination place. Okay. So x new equals to x old plus shx into z old, and y new equals to y old plus shy into z old. Okay. So in this way we can find out the equation. The equation is here, all of you remember it. And the matrix form is for this z axis is x new, y new, z new 1 equals to 1 0 shx 0 0 1 shy 0 0 0 1 0 0 0 0 1 into x old, y old, z old 1. So this one is our z axis matrix. Okay. All of you remember these things. This one is matrix form, and this one is our equation. Okay. So that's all in this class. We can cover shearing and rotation. Okay. All of you go through it and clearly note down it in your copy and also learn it. Okay.